Hello everyone, welcome to the next video of operating system. So we are going to do shortest job first scheduling algorithm for assigning the jobs to the CPU. Now there are some important considerations for the shortest job first scheduling algorithm. So what are these considerations? So first of all, in shortest job first, it is also known as shortest process next. Shortest process next algorithm. Okay. Second, it is a non-preemptive mode. It is a non-preemptive mode of execution. Okay. However, there is a preemptive version. So the preemptive version of shortest job first is known as shortest remaining time first. Shortest remaining time first. Okay. And in this shortest job first, the process with smallest burst time is allotted to CPU, is given to CPU for execution. So that means the mode is basically non-preemptive one, and the factor that assigns the jobs to the CPU is the burst time. Okay. Now, if all the processes have same burst time, so if burst time of all the jobs are same, then it works same as, so SJF is basically is reduced to first come first serve algorithm. So if the burst time is same, then it will be treated as a first come first serve algorithm. So what is the basic advantage of this? So this basically minimizes the average response time. Average response time. So if you are using the shortest job first and you have the intention of response time to minimize the response time to the processes, then this is an optimal algorithm for that. And also there is a limitation in this, so we can consider that as an advantage here, but there is a limitation also for using the SGF, is that there can be a starvation. So starvation can occur because it might be possible that whenever multiple processes are there, so when, let's suppose we have a P1, P2, P3, different processes are there, and new processes are being generated all the time. So if, let's suppose, the burst time of P3 is very large, it's very large, so all the new processes that are being generated have short burst time, then every time the smallest burst times are being executed, and the process with the large burst time will not be given to the CPU, and that may lead to the starvation. That means the CPU will not be given to the process which will have the large burst time. Okay, so starvation can be there. It can be considered as a limitation of shortest job first algorithm. Okay, and also sometimes it is difficult to predict the burst time for new processes. So burst time, whenever new processes are being added every time, so it is difficult to predict the burst time. Okay, so these are the different aspects of shortest job first algorithm for scheduling. Now let's do one numerical for practice, for understanding how shortest job first works basically. So let's assume we have different processes along with the arrival time and the burst time given to us. So let's suppose we have the process number 1, P1, then we have arrival time and we are given the burst time. So we have a process number 1 with the arrival time, let's suppose 1, 7, we have a P2 with arrival time 2 and burst time 5, then we have a P3, then we have P4, then we have P5. So let's suppose this is one random example where we are given a 5 processes with different arrival time and different burst time. Now how we are going to find the average waiting time and average response time, or average turnaround time more specifically? So for that we are using the data structure, the Gantt chart. Okay, so Gantt chart we are going to use here. So we assume that different processes are there having different burst time, and we are going to use the shortest job first algorithm, and it's non-preemptive version. Okay, so if you remember in the first come first serve video, I have discussed how to make the complete table. So alphabetically you will write the completion time, then you write the turnaround time, and then you write the waiting time. Okay, so using the Gantt chart, now the initial process that arrives in the memory, it is P1, at arrival time is 1 second. So if the clock starts from 0, so 0 to 1 there will not be any process. Okay, so from 1 second or from 1 time unit the process will start. So P1 is there, so P1 will execute completely. Why? Because it is a non-preemptive. Even though all the processes will be there in the memory, P2 is also there, P3, P4, P5, P2 arrives at 2 seconds or 2 units, P3 at 3, P4 at 4, P5 at 5, and P1 is being executed by the CPU. It will not be preemptive by the other processes. Why? Because it is non-preemptive. So once a process is allocated to the CPU, it has to complete. Now we know that all the remaining 4 processes have arrived. Now the CPU will follow the shortest job first. So out of these 4, which one is the shortest one? It is the P3. So P3 will execute for 1 second or 1 time unit. So P3 gets completed. Let's cross it. P1 is also done. Let's cross it. Then next process, next shortest job is P4. Time units is 2. So P4 is also 2. Then it comes P2, 16. Because it is of 5 time units, it also gets completed. Then finally P5 of 8 time units, it will give you 16 plus 8, 24. So that's your completed version. And the completion time, you start from the right side. If you remember, in order to write the completion time, we start from the right side. So P5 is completed at 24 time units. Then P2 is completed, which is at 16 time units. Then P4 is there at 11 time units. P3 is there 9 time units, and P1 is there at 8 time units. Now the turnaround time. Now what was the formula of the turnaround time? It was CT minus AT. So you just subtract CT and AT here. So subtracting the column by column, you have 7, 16 minus 2 is 12, 9 minus 3 is 6, 7 and 19. Similarly, what is the formula of waiting time? It was your TAT minus burst time. So TAT minus burst time. So you just subtract this column with this column. So you get 0 here, 12 minus 5, 7, 5, 5 and 11. So the average turnaround time that comes out to be, you have 7 plus 12 plus 6 plus 7 plus 19 divided by how many processes we are having? 5 processes we are having here. So we add this, it will become your 26 until 38, and 13 will give you 53. So that is approximately 10.6. So that is your average turnaround. And if we want to calculate the average waiting time, so just add 0 plus 7 plus 5 plus 5 plus 11 divided by 5. It comes out to be 5 plus 5, 10, 10 plus 11, 21, 28 by 5. So it comes out to be 5.6. Okay. So that's your average turnaround time and average waiting time. I hope this example of shortest job first, the non-primitive version, is clear. How we are going to solve it step by step. Okay. So that's your shortest job first algorithm with non-preemptive version. So I'll share these notes in the description. The link will be available in the description, and we'll do the primitive version of shortest job first in the next video, and we'll solve one more numerical in order to understand how the shortest job first with preemption works. Okay dear, thank you everyone.